This is a 3D printed RC excavator, and not only can it dredge up rocks out of the creek behind your house, load your nephew's dump truck, or construct this perfect Jenga block tower, but most impressive of all is that it can entertain 3 fully grown men for hours on end. A big part of that, and what makes this excavator so unique, is that it doesn't just have a bucket, which by itself pretty much only lets you scoop up loose material. Instead, it also has a fully independent thumb, which unlocks the ability to pick anything and everything up. If that's not enough, you can automatically detach from the bucket and reattach to this ripper completely hands-free. Even better is that those attachments can have their own motors and functions, like this claw, which after being coupled to can spin and clamp. Now, I've spent months designing and iterating this to be as robust as possible, with the hope of making the ultimate beach toy for my family. But what really separates this project is that for the first time on this channel, not only is there a robotic style version controlled by a PlayStation or Xbox controller, but also one that can be built and controlled with traditional RC parts. Kicking this project off, I laid down a 2D sketch of what I want this excavator to look like. Usually, I really take my time during this step, sometimes stretching it out over 2 to 3 days, but for this case, I had a pretty good idea in mind on what I wanted this to look like. Basically, just a large mining class excavator like the Cat 395 or Komatsu PC 900. The reason for these references is, let's say my original RC excavator was around the size of a Cat 320, well, I want this new one to be much heavier duty, which to me places it right in that Cat 395 spot. The reason I chose a bigger excavator for the next project is because I wanted one that could be used outside in the sand and dirt. Now don't get me wrong, you can use this smaller excavator outside, but I really only designed it for indoor desk use. Driving it in the sand will eat away at the N20 motors as they're all completely exposed to the elements. This leads me to requirement number 1 for this project. All of the motors need to be completely enclosed so as to not let any dirt or grime in. For the tracks, I've decided to go with these 12-volt right angle motors as I did a bunch of virtual testing, and while the motors I used in the dozer are more efficient, the diameter is just a bit too large to feasibly fit in the tracks. They just stick out way too far. These will still provide more than enough power for the excavator, as most of its utility comes from the arm versus the dozer, where literally all of its utility is being able to push and move heavy things via the track motors. After nudging and pulling at all the different proportions of the original sketch, I finally got it to a place I was happy with. So I cloned that one sketch a half dozen times, separating it out into all of its core components, such as the body, cab, boom, dipper, etc. I found that just jumping to this extrusion step early on really helps me tune out any weird proportions that might mess me up later. It also lets you mock up all the motors and push rods immediately so that you can verify everything has room to actually be mounted. At this stage, I did find myself getting a little overwhelmed, as with an excavator, there's just so many moving parts and sub-assemblies. But for the sake of progress, I narrowed my vision and just focused on the carriage, which lets the top half of the excavator rotate independently from the tracks. I went with a ring gear design on the lower carriage that can be spun via this pinion gear mounted to a motor on the lower body. This massive 80mm bearing bridges the gap between the two pieces and will seal out any dust and debris. One huge benefit of building this model bigger is that it gives me more room to incorporate these bearings, which just makes the model so much more efficient and durable. For instance, moving onto the track and track supports, every roller that contacts the track is supported on a bearing, which without even testing anything, I know will make a huge difference versus the older excavator where it's just plastic on plastic. That's a lot of friction. I was able to cheat a little bit on the track as I knew I wanted to use a design similar to the one I made for the dozer, as I've already invested a ton of time optimizing it to run smoothly, as well as purge debris that makes its way into the tracks. Before officially starting any of the printing though, I wanted to add detail to the cab, body, and arm. Looking at this from the assembly point of view, I'm starting to get that heavy duty look I was hoping for. The first round of prints for the track assembly came out great. but almost immediately I started having fitment issues, like the cutouts for these bearings being a little bit too loose and the slot to fit the track rollers in not being flexible enough to allow the rollers to pop into place. Not sure why I thought they'd be able to flex that much, but ultimately I split the entire support into two pieces that hold all of the bearings while sandwiching the rollers in place. The secondary idlers that pivot back and forth proved to be a bit of a pain, but ultimately I ended up modifying the design so that every roller only uses one bearing instead of two. This way you only need to buy one pack of 20 versus two packs of 20. Before committing to really printing off a TPU track, which takes over 7 hours, I first robbed the dozer of its track to see just how close it was to fitting on this model. Unfortunately, it was on the smaller side. So the first track iteration, I leaned on the side of too big, and wouldn't you know it, it was indeed much too big. But it was still cool to assemble everything and see it get to move under its own power for the first time. The second track came out too small, but the third fit perfectly. Pressing the 80mm bearing into place took a good amount of force, but after testing how much leverage it takes to pry it up out of place, I think I'm going to incorporate some kind of system where screws can be threaded in to really lock it into place. After pulling the lower body off the printer, I swapped the bearing over and pressed the two halves together, which gave me a good idea on how this is all going to work. This was also my first time really seeing just how much bigger this excavator is going to be than its predecessor. The carriage rotation is powered by a right angle motor, same as what's going in the tracks. To transmit power from the upper half, where all the motor controllers and batteries are, down to the track motors, I'll be using this 6-wire slip ring. The beauty of this is that you'll be able to indefinitely spin the two halves separately without ever tangling any wires or hitting a hard stop, like what's common with a lot of RC excavators. At least until the cab unscrews. With the tracks and track supports now having been iterated at least a couple of times each, it's finally time to solder the motors into place and take it for its first crawl. This is essentially my child taking its first steps out into the world. Everything functioned perfectly except for the fact that my track drivers have this severe wobble, which, after pulling it apart and looking at it, these flat standoffs to lock the motor shafts in place were digging in too far, which, when pressed onto the motor, would cause them to bend off to one side. I ultimately just removed the flat spots and doubled down on the grub screws being what keeps it all locked together. And after some testing, it was a successful solution. Printing off the arm did make me laugh a little, is just looking at the bucket of the OG excavator versus this new one really puts it into perspective on just how many more beans you'll be able to scoop. Scoop. This thing is gonna have some serious scoopage power, but as you might notice, it's not connected to the dipper. I may have gotten carried away and just jumped straight to designing and printing the automatic coupler. I also failed to film any of the assembly, but here it is all together. Because I haven't wired up the new electronics yet, I'm just piggybacking the one servo off of my old excavator board for the time being. Now, if you've never seen an excavator in real life with an auto coupler, basically how it works is it hooks into the attachment on the front, tilts it back, and then swings out another hook that catches a bar, and voila, your attachment is locked in place. That's pretty much exactly how I designed mine to work, except with one small modification: this magnetic strip. At first, I was planning on using two of these 2-pin circular magnets that would shoot out to the side, kind of similar to what I did on the wheel loader, but then I realized the linkage coming off the servo to make this happen would take up a lot of space. It's far simpler to just place the magnet on the coupling bar itself, which can then just swing up and contact a receiving magnet on the attachment, if it has one. Here, I'm just coupling to the bucket, which of course has no powered functions, so no magnet is required. This being the first iteration of this design, it was of course absolute trash. While it did lock into the bucket itself was super loose. Then, even more egregious was the fact that when you try to uncouple, there's nothing holding the front hooks in place, so there's a 50-50 chance that instead of the rear hook coming forward, the front hook will come back. This is only made much worse when there's a magnet holding it forward. I fixed this by just making this little notch/shelf so that after hooking into the bucket, you tilt it all the way in so that it rests like this. Then when uncoupling, the front is forced to slide backward, making the magnet uncouple. Now that I've scratched the mechanism itch, I tested the curl function, which, other than some parts needing to be clearanced and the motor itself needing to be about twice as fast, it worked decently well. But before printing the rest of the arm, I decided to print out some more of the body and accent pieces, so that I could get a better feel as to how this is all going to look. The body came out great. There's a little bit of overhang gunk on the rear hatch logo, but I'm not sure it's bad enough to justify printing a separate piece and slotting it into place. The cab and ladders all get mounted with one screw each, and then the cab receives this, in my opinion, sick cab cage. To me, this really just makes it look a little more heavy duty or Mad Max-like. The only logical thing to do at this point was assemble everything together. Stand back and admire a month of hard work. Side by side, you can really see just how much bigger this thing is. Which, one thing I'm particularly excited about is just how much higher the boom will be able to reach. I received positive feedback on the physical latch I used in the dozer. A really common occurrence is for someone to want to pick the model up and look at it, which makes sense. Well, when it's only small tabs holding the rear hatch on, and that's where they grab, it just pulls apart, leaving you in an awkward situation. These physical latches, though, give you a bit more peace of mind if someone comes and picks your model up. I did some basic tests with the dipper motor to see how much weight it could push, and what I'm really looking for here is if it can do a full body push-up, for parkour reasons. It did do it, but I have a feeling there might be a bit of a struggle once the rest of the model is in place, so I may need to decrease the gearing on this motor to get a little bit more torque out of it. For the electronics on this excavator, I started by figuring out how many motor outputs I needed. Figure 2 for the tracks, 1 for the carriage, and 4 for the arm. That covers all the essential motions, including the thumb, putting us at a total of 7. With 4 of these dual bridge H-bridges, that gives us 8 motor outputs, meaning we'd have 1 spare. Preferably, I'd like to have at least 2 spare motor functions, so I added another H-bridge, giving us a total of 10 motor outputs or 3 spare motor outputs. Now, controlling all 10 of those motor outputs is where things get tricky. One ESP32 development board, which is what I use as the brain for all of these projects and is what connects to this PlayStation controller, only has enough outputs to reasonably control 5 to 6 motor outputs. There's multiple different ways to solve this. For instance, on the original excavator, which has 8 outputs, I used this MCP23017 port expander, which basically just lets you route in a couple pins from the ESP32 that can then be used to control 16 outputs/inputs, depending on the signals you're sending to it. There's 2 problems with this approach. The first is that proportional control is much harder, if not impossible, to achieve, as you can really only send on and off signals to the motors via that expander. So it's really only all or nothing for motor movement. Because this model is so much bigger, I would like to have finer control. The second reason I don't want to use this port expander is the cost. The ones I usually get are about $10 a pop, not terrible, but not great. In other countries, like Australia, I've had people who can only find ones for $30 to $40, or they just can't find them at all. Because of this, it's for sure a no-go. Oh, and I guess there's also the fact you have to solder in these resistors to make it work, and while not a total deal breaker, I won't miss having that extra step. My alternative is simple. I'm just going to add another ESP32. Now, I know for a fact you can get these absolutely everywhere and for only about $5 US a piece. The reason I didn't do this on the original excavator was because I had space constraints. There was absolutely no way to fit another ESP32 inside the rear hatch. This bigger excavator, though, should have plenty of space. The final key to the electronics is this buck converter, which will take the 12 volts coming from the batteries and drop it down to a lower voltage for the ESP32 and servos. With all of that figured out, I hopped into my PCB designer and laid out all the pieces, followed by making all the connections. With everything connected, I started building the actual circuit board itself. If this looks really complicated, don't worry, it's really not. I'm basically just playing connect the dots, with the real challenge being to make everything as neat as possible. Once satisfied, I absolutely slammed the order now button, and 4 days later, I got the boards. The reason for this board versus just wiring everything together physically is, well, there's about 100 different connections that need to happen. Soldering a harness for all of those would be terrible. I wouldn't wish that on my worst enemy. This, on the other hand, makes everything super neat and tidy. You just solder the headers and terminal blocks on from one side, then that lets you plug everything into place. Before installing this PCB though, I figured it might actually be a good idea to finish getting the excavator ready to receive it, starting with the arm motors, which upon testing had enough power to rip the threads out of the lower chassis. Definitely going to add some more mounting slots for those. But for now, a little hot glue is gonna have to hold it. I swapped out the carriage to be a bit wider and give the model more overall stance. Can't be having an excavator that skips leg day. Finally, I soldered on 2 runs of wire to the magnet just so I don't have to blow this whole thing apart later to do it. To power this beast, I've got 3 of these Phoenix 18650 2600 milliamp batteries. You could absolutely just use a traditional 3S LiPo battery for this, but given this is more like a robotics project where people are learning and potentially soldering things for the first time, I much prefer these batteries as they have overcurrent protection, meaning you can short circuit something and not have to worry about damaging the battery. It instead just shuts off until the model is restarted. Also, instead of having to have a whole charger setup like a traditional RC car battery, you can instead just use the micro USB that's directly built in. Phoenix, if you ever watch this video, I want you to know I've directly promoted your business to millions of people and never received a dime. So maybe think about sending me a headlamp or something. Speaking of promoting though, I did buy this roll of PETG from Overture, and guys, I don't know what happened, but never have I come across a roll of filament that had such weak layer adhesion to itself, but fantastic adhesion to my build plate. Bad, Overture, bad. Anyways, back to more pressing matters. The 3 Phoenix batteries get pressed into this 3D printed battery holder. Powering on the excavator, you wouldn't believe it, absolutely nothing happened. At first, I wasn't worried, as usually I'll forget to put in the fuse, or maybe one of the batteries is dead. But after running through my initial checklist of likely culprits, I still had no life from the ESP32s. Ultimately, I found out that this entire row of headers for the H-bridges were backwards, meaning I had shorts on every single one of them. Once I removed the H-bridges, my ESP32s started getting power. Now this really sucked because I was super pumped to finally get this thing moving under its own power, and it was going to take another 3 to 7 days to get the fixed batch of boards in. Ultimately, I banged my head off the wall a couple times and then decided to spend a day soldering a new circuit board, but with these twisted ribbons that flip the connection for each H-bridge. After verifying this Frankenstein PCB was receiving power, the final thing to do was write the code for the excavator. I'll save you the boring bits, but basically the important thing to know is one ESP32 acts as the primary board, communicating with the PlayStation controller and then handling a couple of the motor commands. Any motor that it's not in control of, it simply tells the second ESP32 via the RxTX signal what motor needs to be moved and how fast to move it. Uploading the 2 different code versions, I finally had a model that moved. For the control layout, I placed all of the arm functions on the joysticks and set it up to mirror ISO controls. Basically, if you were to drive an excavator in real life, the joystick controls would mirror these joystick controls. And I think that's pretty cool. So if you're a heavy equipment teaching institution, hit me up. The tracks I set to the bumpers and triggers. To really break this thing in, I of course did a couple hot laps on my floor, messing with anything that came into reach, like this box. But what I was actually itching to try is coupling into an attachment, which went a little something like this.
I'm a genius!
Having the thumb is definitely what makes these excavators so fun to play with, at least in my opinion. Unfortunately, the thumb I have installed right now is geared too high, so you can't really clamp onto anything without the tension back driving it, like this mallet. I have more than enough power to squeeze it, but once I let go of the control, the thumb back drives, loosening its grip. I did try and do a full power squeeze, which resulted in this. A broken coupler plate. That's going to need some reinforcing. Which actually leads me into the next thing I want to tackle for this model, a functional rotating claw attachment. The OG excavator with its claw is by far one of my favorite machines to operate, as you can really construct some awesome towers out of anything with it. My hope is to recreate a similar feeling here, but what will be cool with this is you'll be able to retain the thumb function if you so choose. I came up with this worm gear style claw where the two sides mesh into a worm gear that's spun by an N20 motor. While it was really fun to design, I just couldn't get it to work super well. This gold black iteration was my third attempt, and honestly, at this point, I was pretty sick of it, so I just said to heck with it and designed this trenching bucket instead, as well as this ripper for breaking up material. With those done, I moved everything to my display table so I could really put it to the test. I started by hooking into the large bucket first, and then without skipping a beat, I beelined it straight for the mountain. This is usually the first proving ground for all of my projects, and unfortunately, over time, a lot of the grippy material has gotten torn away, hence the tracks slipping here. But luckily for the excavator, I was able to just drag myself up the hill using the arm. Navigating all the lumps and trees was definitely its own challenge with this large of a model, and the tree population, hate to say it, took a hit from this venture. The bridge was a good test on stability, and I'm honestly just shocked that these little posts managed to stay stuck in the mountain, as they're just held in with a little bit of hot glue. I'm telling you, having this arm turns this into the ultimate off-roading machine. If you can't climb it, you can instead just do a one-arm push-up over it. I did decide to pass on driving it back down, as I had already done enough damage to my mountain. In the last video, I cleaned up all the beans and swapped it out for dirt because it was for a tractor. But now that I finished that, definitely throwing the beans back on the table. And let me tell you, these first couple scoops are like your first sips of coffee in the morning. Life inspiring. I also checked that the track would purge any debris that made its way in by mashing the tracks through the beans, and while it did pick up a lot of them, it didn't take long for them all to get purged out, which is exactly what I was looking for. Filling up this side dump was something I had in mind when building this project. The original excavator was just not to the right scale in order to fill it up in any reasonable amount of time. Seriously, it would probably take 20 minutes to fill it all the way up. The wheel loader was a game changer for this, but I'd still like the excavator to be able to do the job as well, which it absolutely does. As a bonus, if your truck driver parks too close to you, or maybe they just ate your lunch yesterday, you can literally pick up the entire side dump and give them the ride of their life. For those of you wondering, it takes about 8 scoops to fill the side dump up, and I definitely think there's room to make a bigger bean scooper in the future.
Nice.
Dropping the bucket and swapping over to the claw, I first thought that I was just really trash at auto coupling or that something was broken, but after looking at it, I realized I just forgot to remove these supports in the back. With those out, I hooked up no problem. This claw has the potential to be really, really cool. Picking up and spinning the trenching bucket gives you an idea on just how precise you could be. Unfortunately, all of my controls were backwards and in opposite order, so that really made my life difficult. Despite that, I did try moving some sticks around, and by about the third stick, I was again having some issues with the claw, so I decided enough was enough and that it's once again going to need a total overhaul. The Ripper though, that I was excited to try. But unfortunately, it was a short-lived experience. This coupling plate is just not strong enough when printed in this orientation, especially with how much force is coming from these push rods. The weakest point of any 3D print is the layer lines themselves. Without splitting this one piece into at least 3 separate parts, I decided to just try printing it on its side. The layer lines will now run with the incoming force, making it as strong as it could possibly be. The downside though is that the support material can be a bit of a pain to remove, but the results are 100% worth it. I absolutely cranked on these attachments trying to cut this cardboard, and it didn't even budge. Plus, by working the Ripper back and forth, I was able to cut a nice groove. If you don't think that's impressive, I highly encourage you to try cutting through some cardboard with a dull 1/8 inch piece of anything like I'm doing here. It actually takes a lot more force than you think. Applying the Ripper to a more real-world scenario, I took it out to a creek and used it to break up some rocks and mud, which it excelled at. Unfortunately, I failed to record the bucket going in after and scooping it up, but I instead did capture this dredging footage, which honestly, I could watch all day. This is the kind of stuff that just makes me love building and using these RCs. I could spend literal hours dredging up mud and rocks. It just kind of takes your mind off things and you kind of stumble upon little side missions and quests. For instance, moving this stick further out into the water. Then maybe you go back to dredging mud for a bit, but then you decide you actually want to pick that stick back up again and take it for a little adventure, which I did. At this point, the excavator was holding up really well, which was honestly a bit surprising, as usually when I'm performing these first initial real-world tests, stuff either breaks or I realize there's not enough usable power. But not with this, it just kept on cruising, and to really prove that point, I decided to do a long stress test by driving out to this little island and just dredging up rocks and dirt for an extended period. After a while, my batteries still showed no signs of dying, so I handed the controller over to a buddy and had him try it out. Now with over 8 different controls to figure out, this can be a pretty tall order for somebody new. But he's operated excavators before in real life, as well as past models of mine, so in pretty much no time at all, he was scooping mud and trying to pick up sticks on the shore. One thing that did really become evident though, is that the crossover between the controls on each stick is hard to avoid unless you keep it dead centered along its axis. So I think I'll code in a bit more of a gap so that when you're just trying to curl the bucket in, you're not also accidentally moving the boom up. At this point, I printed off everything for a second excavator so that I could really see all the changes that had been made come together. I'll be making this one with standard RC components so as to be controlled by this RC transmitter. Now, one final thing that's been really driving me up the wall is the claw. I ultimately just decided to swap the N20 motors out for this 20 kilogram servo. Not only will it have way more power, but it'll also hold its position and not loosen / backdrive when squeezing or clamping down on something, which was exactly the change I needed to make in order to start successfully stacking log decks and recovering some stuck equipment. I couldn't be happier with how it turned out. Alright, my main goal for this project was to make something that could be used in the sand and dirt. And there's no better way to actually test that than recruiting the boys and rolling up to the beach in style. All jokes aside, my brother, uncle, and I were legitimately entertained for hours. Particularly my brother. We share the same brain, so toy RC equipment also very much triggers his dopamine receptors. Things started off by digging this piece of driftwood up out of the sand, but then devolved into a fight on whose it actually was. Then of course, we loaded the side dump on the RC semi and dumped it over this cliff, which got us thinking that building a ramp down to the water seemed like a fun idea, so everybody migrated in that direction. The sand over here was way tougher as the water had turned it into more of a hard pack, and while it was possible to get some sand if you scooped shallow enough, the real ticket ended up being one person swapping over to the ripper, loosening up the material while the other came at it with the bucket. This allowed us to slowly chip away at the ledge, plus adding the dozer into the mix was great for pushing in excess material. After about 15 minutes of work, we did successfully make our way down to the water, where we then debated on whether or not to start building some kind of seawall to hold back the water, but unfortunately we had to get going, and that pretty much concludes our beach day, which I'm calling a huge success. Now, if you want to 3D print and build your own RC excavator, you can by joining the Professor Boots workshop on my website, professorboots.com. There I have all the 3D files and step-by-step guides that'll take you through how to 3D print the parts, source components, coding, assembly, etc. Once you join the workshop, you'll have access to all 11 builds, as well as weekly update videos under the build log section. For instance, workshop members have actually been following along with this excavator since May. The workshop is the primary way this channel is supported and how I get time to actually build, test, and make these videos. So a huge thank you to everyone who's a member. Now, for the next project, as always, whatever piece of machinery gets the most comments down below will be the next project. For example, an updated skid steer, road grader, crawler crane. You choose it and I'll do my best to build it. With that, thank you all so much for watching, and I'll see you here soon with another build.